All right, hello. Today we're going to be talking about subtracting fractions. And specifically, we're going to be focusing on mixed numbers and changing to improper fractions. So let's get a look at what that looks like to start out with. You can see we always like to start out with a model of what that looks like. If you prefer to just go straight to the numbers, you're like, I get this. Okay, cool. Then skip ahead just a couple minutes in the video and we'll get to just the numbers part of it. But we always like to demonstrate with some modeling just so you get a good picture of what's happening. So if we have 2 and 3/4 and we want to talk about the difference, of course the difference means to subtract. So what we're trying to do here is we're taking 2 and 3/4 and we're going to subtract off 1 and 1/4. Now the 2 right here, we can see we have two whole parts. That's this one and this one. And then we have 3/4. 1, 2, 3. For the other one we have 1 and 1/4. So here's 1. And then you can see we broke the circle up into fourths and we have one of them shaded. Now, if we want to then subtract those and find the difference between them, then you can see that what we're going to do is we're going to take one of these away from that. So that's how you can see where we're just going to cross it out. And we're going to take off one of these parts. So we cross that out. And what we have left is this dark part here, which we have one whole part and then half of a circle, so 1 1/2. That's how we can say 2 and 3/4 minus 1 and 1/4 is 1 1/2. Now, just numbers-wise, if you look at this, you can see 3/4 and 1/4. Well, those have common denominators already. And you can actually just do 3/4 minus 1/4, and that much of it, anyways, will be 2/4. And then for the other part, you can take the 2 minus the 1, and you can just get 1. So 1 and 2/4, which of course becomes 1 and 1/2. And that's just the numbers if you don't use the modeling. Now we can take those, that was using mixed numbers. We can also do that using improper fractions, and it really just kind of has a little bit of a little finesse to it. The more you do this, the easier it becomes to decide which is which. There's not one right way and one wrong way. It's just sometimes some are a little easier than others. Okay, so here's one where if we want to do this same problem, but we're going to use improper fractions, instead of leaving these as wholes, we went ahead and broke those up into fourths. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fourths. And over here we've got 5/4. And so if we take 11/4 minus 5/4, of course we get 6/4, and that reduces down to 3/2. Of course 3/2 is 1 and 1/2. Okay, so those are equivalent. And it doesn't matter which way you do it. It really doesn't matter that much. So let's see this. Are these equivalent? Yes. Yes, they are. So you can use either one. What's the difference in the techniques? Well, one of them was changing to an improper fraction, and then of course these numbers the numerators would get a little bit larger, right? 11 was definitely larger than anything else we had. Does it matter which technique you use? Not really. I mean, personally, I will typically use the second one. But in a case like this one's super easy to do with the first one. Here's why. Because we already had common denominators, and I could specifically see that this fractional part in the first one is larger than the second one. And so that means I didn't have to do any borrowing. If for some reason, if I had 2 and 1/4 minus 1 and 3/4, if I had those switched around, doing these as mixed numbers is a lot more challenging because then you have to borrow from the whole, and it's a whole thing. Okay, but so I typically prefer to use this method. Why is that jumping? I prefer to use this method most of the time. Now, also, if you have really large mixed numbers, like if this was 237 out front, if the whole part was a really large number, then maybe using improper fractions isn't always ideal. Okay, let's go ahead and look at a few other examples. All right, so we're going to model the difference between 2 and 4/5 and 2 and 1/5. Now, this is one that I think probably I would use mixed numbers on. That's because we have common denominators already, and I can see that 4/5 is larger than 1/5, and so I don't need to do any borrowing on this in order to do it. Okay, so my first number here, I'm just going to use circles here if I want to model the difference. So we'll take 2 whole parts, and we'll have one more, and we'll break it up into fifths. That's pretty close, right? So there's 2 and 4/5. Here's 2, well, actually, that's just 2. I haven't colored them in yet. And this one's really bad. All right, there we go. So we've got the first number is going to be 1 whole, 2 wholes, and then 4/5, right? So 4 of these parts are going to be colored in. There we go. And then for the other one, we need 2 and 1/5. So we've got 1, 2, and 1/5. And this is what we're going to take away. So if we take all those away, you can see that what's going to happen here is if I take those away, so there's 1, there's 2, so the whole parts are all gone. And I'm going to take away this guy here and just one of those. And you can see all that's left is just 3/5. Right? The whole parts are all gone. And the only thing that we have left is just 1, 2, 3/5. Okay? So the equation that I could use for that is actually just written right up there. It's 2 and 4/5 minus 2 and 1/5 makes 0 whole parts. There is no mixed number to this. It ends up being just a fraction. And I have 4/5 minus 1/5 is 3/5. And that's this guy right here. Okay, let's take a look at this one now. This one you could use improper fractions for, or you could use mixed numbers, but the hard part about this is we do have denominators that are not the same. And because our denominators are not the same, that means that we've got to get common denominators. So let's go ahead and draw out what this looks like. And I'm going to use rectangles this time. Why? Just because I feel like it. So here's 2, and then 1/2 will look like that, right? And then we've got 1 and 1/4. Now the nice thing about this here is that fourths and halves, those go together really well. I know what the common denominator is going to be for those. It's going to be fourths, right? All we've got to do actually is split this half up. We'll just do this. There. Now instead of 2.5, what we have is actually 2 and 2/4, and this is 1 and 1/4. And if I start taking those away, we can do this. It's like that's done. Okay, those will pair up and cancel out. And then you can see that all I have left is I have this one whole part right here, and I have one of these little parts left over. So my answer is going to be 1 whole part, and then just 1 of these fourths. So we'll have this much here, this much down here. Now you also could have done this with improper fractions, we said. For example, if I changed all of these whole parts into fourths, like this, and I did it over here as well, then you could see that what I would have, I'm going to come right below this, I would have 4, 8, 10, so I'd have 10 fourths. And over here I have 1, 2, 3, 4, 5. That would give me 5 fourths. And 10/4 minus 5/4 is just 5/4. Now, it is true that 5/4 equals 1 and 1/4. So these are equivalent answers, different numbers that mean the same amount. Okay? All right. Let's go ahead and take a look at a few more now. Why don't you go ahead and try this one? See if you can model it. We've got 1 2/3 and 1/2. And I'm going to go ahead and just pause it here. Try to do your own, and then come up with your answer, and I'll get the answer written up here. Okay? All right, so I've got all my circles up here. And you can see we've got our 1 2/3. This was 2/3, and I split it up so they'd be sixths. And then we've got our 1/2, which is 3/6. And this is what we want to take away. So I've got 1 4/6 minus 3/6. And when we take away, it's like undoing. So I can take this, just put it right here, and that means that part's going to just go away. So this is gone. And all I have left is just the yellow parts here. Okay? So that would leave me with, well, it looks like I have one whole part, right? And then I've got just this one little yellow guy left over here. So, and we'll just have one little part there. Okay, so we get 1 1/6 is our answer. Now, if you did that with improper fractions, what you might have is 10/6 minus 3/6 equals 7/6. 7/6 and 1 1/6 are the same amount. Okay. All right. Here's another one. Go ahead and get your pictures drawn. See if you can model it. At the very least, come up with your equation. Here's the start of it. If you haven't done it already, but you should probably pause and try to do this on your own. Okay. So I'll get these colored in. I'll stop talking and. You do this. Pause the video. All right. I'm gonna go right to the answer now. All right. So what we've got here is this one is going to cancel here, and then this one is going to cancel with some of these, but it's only going to cancel with some of them. So I better make sure I cancel the right amount. Okay. So we'll do this, and I'm going to come through and cancel. Okay. Here's 1/4. There's 1/4. There's 1/4. There's 1/4. There's 1/4. There's 1/4. Because when we're subtracting, that's what we do, is we're gonna pair them up and make them go away. And what I have left now is I have one whole part left, and that's this guy right here. And then I also have 1/4 left over, and that's this one here. So we end up with 1 1/4. And if you did this with improper fractions instead, if you like that way, you would have 11/4 minus 7/4 equals, oh, wait a minute. That's not 11/4, that's 12/4. There, because I was looking here. But we do have all 12 parts here in the original amount are shaded. I just counted wrong. So we have 12/4 minus 7/4 equals 5/4. Okay. And as you're doing your homework, this is probably the more appropriate answer. I think you'll see that most of the time on the homework, it's going to ask for improper fractions. It's just a little easier to work with improper fractions most of the time. Okay. So when we talk about subtracting whole numbers, mixed numbers, and fractions, we have two different types of problems, or two different techniques, right? So number one, what we could do is we can do the whole minus the whole. We'll do that part first, and then we can also do the fraction minus, fraction minus fraction. And that's kind of nice to do sometimes. It's a little bit easier sometimes, and it just takes a little bit of practice to figure out when it's easier. The second technique, right, is to do something like this. Step 1, change to improper fraction. Then what we're going to do is get common denominators. Then we subtract the numerators. And leave denominators. 4, simplify. Always simplify. We don't want to leave fractions in an unsimplified form. Okay? All right, we've got just a few more problems here to work on today. I think I've got 5 more problems left to work on. So let's do the first 2. We'll do the first 2 leaving them as mixed numbers, and we'll do the second 2 using our second technique, which is the changing everything to an improper fraction. So for this first one, if I want to take 15 and 15/26 minus 6, then I'm going to do just the whole parts first. Okay, so I have 15 minus 6, so we'll do the whole minus whole, and so that's just 15 minus 6. I was really thinking about it here. There it is. So now we've got, that part's 9, and then 15/26 minus nothing. Like, because there is no fractional part here. This is just a whole number. There's no fractional part. So 15/26 minus 0 is still 15/26. So our answer to this is 9 and 15/26. That's not so bad. All right, this other one, though, you can see that what we have is a whole number minus a mixed number. So you can see up here that sometimes subtraction of mixed numbers involves borrowing. This is what I was talking about earlier, where it can get a little complicated. And this one's not too bad because we don't have another fractional part to work on. But it says, turn the whole one into a fraction such as 4/4. We have to borrow from this 12. See, what we're trying to do is take 12 and 0/16 minus 7 and 15/16. In fact, you know, I'm going to write these vertically so you might be able to see what matches up a little bit better. So 7 and 15/16. Now, if I try to take 15 away from 0, it doesn't work. So what I'm going to do is come up here to this 12, and I'm going to borrow from the 12. I'm going to make that 11, and I'm going to add 1 to it. But a mistake that some people make is they say, oh, well, I'll just make that 1. Well, that's silly. We didn't take 1 whole away from this and turn it into a 16th. Think how tiny 16th is, right? When we borrowed 1 whole amount here, whew, there we go. There's 16 pieces, I hope. And so when we borrow from this, we take 1 whole amount. We actually have 16 pieces that we are borrowing. So this isn't going to be 1/16. This becomes 16/16. 12 is the same thing as 11 and 16/16, right? Because think about this right here. This guy right here is a value of 1. 16/16, that part's 1. So 11 and 1 make 12. That's how we get, we've changed 12 into something that is equivalent to 12, but it has common denominators with what we're working on. So let's clear this out, and now we can do the whole minus the whole, and so we get 11 minus 7 is 4, and now I have 16/16 minus 15/16 is 1/16. So I get 4 and 1/16. Okay. Now, if you think about it, that should kind of make sense, because 7 is almost 8. And if I were to take 12 minus 8, everyone knows that's 4. But I'm actually taking away a little bit less than 8. And if I'm taking away a little bit less than 8, then my answer should end up being a little bit more than 4. So this should make sense, right? You could also think of it like this. Taking 12 minus 7 is 5. And now I've got to take 5 minus 15/16. So you could think of it like that as well. You know, we're going to be taking some away from 5, so of course that's going to go down to 4. All right, now that's using mixed numbers and leaving them and borrowing. Let's do this next one. We're going to do it by changing everything to improper fractions. We could do that same idea from before, and I'm just going to show you super fast what that looks like. If I do this, I would borrow from this, and I'd turn this into 16. If I borrowed 1 from the 17, and I made that 16, and what I would do is I would add 5/5 to this. So 17 and 2/5 becomes 16 and 7/5 minus 9 and 4/5 makes 7 and 3/5. Okay, so that's ultimately going to be my answer, but I said we'd do it a different way. And I know that was a little fast, but hopefully you can take what we learned on the last problem. You know, if we borrow from this, that's like 16 and 5/5, and then I still have my 2/5 there already. So that's how I get 7/5. Okay, but I said we'd do this a different way, so we're going to. What I'm going to do for this other one is change it to an improper fraction. So I will take 17 times 5 plus 2. Okay. Let's see, 17 times 5 is 85, plus 2 is 87/5. So this part here becomes 87/5. Easy enough. And then for the other one, I've got 9 and 4/5. So I'm going to do 9 times 5 plus 4, and that will also be over 5 because of our denominator. So that's 45 plus 4 makes 49/5. And now what I'm going to do is take and subtract these. So we've got our 87 minus 49/5. Common denominators, we leave the denominator, just subtract the numerator. Well, 87 minus 50 is 37. So minus 49 is 38. That's 38/5. And yes, those are equivalent. 5 goes into 38 7 whole times with 3 left over. Okay. For the last one here, we'll do this one using improper fractions again. Here's one where I actually really would do this with mixed numbers. I mean, we've got common denominators. These numbers look a little bit big. I don't know that I necessarily really want to multiply 14 and 36 and add 5. I mean, you can, but I really think this is one where after a little bit of practice, I would just be like, you know what, I'm going to borrow. We'll make this 35. You know what, we are going to do it this way. We're going to do it this way because it's just easier. So there's the first one. I changed this 36 into 35 and 14/14. And I still have my, let's go through here. So I've got 36 becomes 35 and 14/14. And then I've got my 5/14, that's this part right here. And so I'm going to end up putting those together, and that's going to become 35 and 19/14. And then for the other one, I'm not going to borrow anything. I don't need to. Like I'm subtracting them. So this just becomes 35 minus 14 is 21. And 19/14 minus 9/14 becomes 10/14. Now we're not all the way done with this, and that's because 10/14, those are both even. And so those will reduce down to, if you divide each by 2, that becomes 5/7. So my final answer is 21 and 5/7 for this. Okay. Now I know some of you are like, oh, you said we were going to do these with improper fractions. Okay. All right, you twisted my arm. We're going to do it with an improper fraction as well. So I'm going to come up here. We'll do this right up here. So this is 36 times 14 plus 5. fourteenths. And I did this over the side. I didn't do this in my head, just so you know. 509 fourteenths. And then we're going to take, for the other one, I'm going to take 14 times 14, and then add 5 to it. And we'll call that over fourteenths. Okay. And then what that becomes, wait, why did I say 5? Oh, that's 9. That's why. Okay. Plus 9 fourteenths. Of course, 14 squared is 196. That's one you might want to know. You should know your squares. And then we're going to add 9 to that and make that 205 fourteenths. Now we can subtract these, and this actually subtracts pretty nicely. 509 minus 205. No borrowing necessary here. That just becomes 304 over 14. 509 minus 205 is 304. And then, of course, this one's an easy one to see. 2 goes into each of those. So 2 goes into this one 152 times. And then, of course, 2 goes into 714 times. So 152 over 7. Now, in a real-life scenario, probably this answer makes more sense. Like if we were talking about how far somebody threw a ball, or I don't know how many hot dogs somebody ate. It makes sense to say 21 and some extra. But mathematically, working with improper fractions a lot of times as you advance through math is a little bit easier. And so I think a lot of your homework questions will have you write things as improper fractions. The inseam of a pant leg is 30.5 inches. What's the inseam after the tailor cuts off 3/4? So he's cutting off. Like that's just prime language there for subtraction, right? So this one, again, it's not too hard to use mixed numbers, but we could go ahead and do improper fractions just because I feel like it right now. That's 30 times 2 plus 1. That's going to be 60 plus 1 is 61. And then, of course, that's over 2. And we're going to take away 3/4. I've got to get common denominators, and so what I'll do is multiply this one by 2 on top and bottom. So that's 122/4 minus 3/4 is 119/4. Now, this is a great time for me to kind of demonstrate, like, oh, the pant leg is 119/4 inches. Like, that doesn't make much sense. But if we do take 119 and divide it by 4, that's going to be 229, and then that's a 7 and 1. So how about 27 and 1/4 inches? Like that probably, no. No. So right here, 11 minus 8 is not 2. 11 minus 8 should be 3. This should be a 39. Well, thanks for yelling at me about that, or at least looking at the screen very confused. That helped me out for you to look at the screen in a very confused fashion. I could feel it coming through the internet here. So I've got, how about 39, and of course 4 goes into 39 9 times. That's 36. There we go. And that's 29 and 3/4. Okay, so much better. So let's do that. That is a much better answer. Now, this is a case, though, where, honestly, I would just subtract the 3/4 off from this, right? Because 30 and 1/2, that's the same thing as 30 and 2/4 minus 3/4. And so I can say that's 29 and 4/4, 2/4 minus 3/4. That's 29 and 6/4 minus 3/4, and then that's how we get this, 29 and 3/4. I think that's a little easier. All right, guys, I know that's a lot of subtraction problems that we did today. I hope that this helps you out a little bit. Please don't make fractions just a horrible math thing. It's not a thing. You use fractions a lot, so if you need to advance pretty far in math, you really got to get comfortable with fractions and finding common denominators and just being super comfortable. The more you do them, the more fluent you'll become in fractions. All right, good luck.